Hi, Assalamualaikum. My name is Nurul Farha binti Ahmad Najib from Group 17. My group and I would like to present about determination of ethanol in wine titration. Let me introduce my team members first. The first one, which is me, Nurul Farha binti Ahmad Najib, and the second one is Nur Zulaika, and the third one is Marsha Balkis, and the number 5 is Ain Farisha, and the last one is Ashira Diana.
Next, we go to the goals. Titration is an analytical technique used to determine the concentration of a specific substance in a solution. This process involves the gradual addition of a titrant, a solution of known concentration, to a solution containing the analyte, the substance whose concentration is to be determined until the reaction reaches completion. The point at which this occurs is known as the equivalence point, which is often indicated by a color change due to an added indicator or by reaching a particular measurement on an instrument. The primary purpose of titration is quantitative analysis. It allows for precise measurement of the concentration of an unknown solution. This is crucial in various fields such as chemistry, biology, environmental science, and medicine. For example, in the pharmaceutical industry, titration is used to ensure the correct dosage of active ingredient in medications. In environmental science, it helps determine the levels of pollutants in water samples.
I'm going to talk about the purpose of wine titration. Alcoholic drinks like wine and beer have additional substances that can be oxidized, necessitating a change in the method used. Wine titration measures the acidity, specifically the titratable acidity, to ensure the wine taste, stability, and quality. It aids in quality control, monitors fermentation, ensures legal compliance, and guides blending decision. Proper acidity balance is crucial for the wine's flavor, profile, and aging potential. This process requires a certain amount of time, and it is essential to allow the sample to remain in the flask in a warm location and leave overnight. I'm going to talk about the purpose of wine titration. Alcoholic drinks like wine and beer have additional substances that can be oxidized, necessitating a change in the method used. Wine titration measures the acidity, specifically the titratable acidity, to ensure the wine taste, stability, and quality. It aids in quality control, monitors fermentation, ensures legal compliance, and guides blending decision. Proper acidity balance is crucial for the wine's flavor, profile, and aging potential. This process requires a certain amount of time, and it is essential to allow the sample to remain in the flask in a warm location and leave overnight. I'm going to talk about the purpose of wine titration. Alcoholic drinks like wine and beer have additional
Next is the theory about the experiment of determination of alcohol in wine. The definition of experiment is ethanol content of the solution of ethanol in water can be measured by acidizing the ethanol to ethanolic acid with the excess of acidified potassium dischromate. The experiment for determining the ethanol content in wine through titration involves a chemical process where the ethanol or alcohol in wine react with the solution, typically a standardized solution of strong acid or strong base. For type of experiment is acid-base titration for an ethanol determination in wine. This experiment for determining the wine using titration fall under the category of analytical chemistry. Specifically, it involves quantitative analysis, where the goal to determine the concentration of particular substance. In this case, ethanol is given as a sample. This type of experiment relies on precise measurement and chemical reaction to determine the amount of analytic present in the sample. It's a fundamental used in various industries, including food and beverage, pharmaceutical, environmental, and monitoring, and more.
Okay, this is the objective for determination of ethanol in wine by titration. For the first one is to accurately determine the ethanol content in a sample of wine using titration. And the second one is to provide precise and reliable measurement of ethanol concentration in wine to support quality assurance, regulatory compliance, and consumer information. Okay, this is the procedures that we follow to run this experiment. For the first one is to dilute beer samples 1:20 ratio, which is 10 ml in 200 ml, and one sample 150 ratio, which is 20 ml in 1000 ml. And the second one is transfer 10 ml of the acid dichromate solution to a 250 ml conical flask with matching rubber stopper. And the third one is pipette 1 ml of the dilute beverage sample of the sample holder, which is 5 ml beaker or glass vial. And number 4 is suspend the sample holder over the dichromate solution and hold in place with the rubber stopper. For step number 5 is store the flask overnight at 25 to 30 Celsius in incubator. And the step number 6 is for the next morning, allow the flask to come to room temperature and then loosen the stopper carefully and remove the sample holder and rinse the walls of the flask. Then add about 100 ml of water and 1 ml of potassium iodine solution and then swirl to mix the solution. And step number 7 is prepare 3-blend titration by adding 10 ml of acid dichromate solution to a conical flask and adding 100 ml of water and 1 ml of potassium iodine solution and then swirl to mix the solution. For the step number 8, fill a burette with sodium thiosulfate solution. Okay, for the last step is titrate each flask with sodium thiosulfate when the brown iodine color fades to yellow, and then add 1 ml of starch solution and keep titrating until the blue color disappears. And then do the blend flask first and repeat until the results are reached. Then do the alcohol samples.
So this is the result that we got for this experiment. We repeat the experiment 3 times because we want to get an accurate result. Firstly, for the calculation, we need to find the average volume of sodium thiosulfate. The result that we got are divided by 4, so we will get 16.13 ml. Next, the concentration of sodium thiosulfate is 0.01152 and the volume of sodium thiosulfate is 16.13 ml. Number 3, we need to find the mole of sodium thiosulfate. So we will use the concentration times with the volume and we will get 0.00186 mole. After that, we need to find the mole of iodine 2. We use the mole of sodium thiosulfate divided by 2 and we will get 0.000093 mole. Number 5, we need to find the moles of acid dichromate 2. So we will use the moles of iodine divided by 3 and we will get 0.000031 mole. Number 6, we need to find the moles of ethanol. So we will use the formula 3/2 times with moles of acid dichromate and we will get 0.000465 mole. For the number 7, we need to find the mass of ethanol. We will use the moles of ethanol times with 46.07 grams per mole and we will get the answer 0.002142 grams. Lastly, number 8, we need to find the percentage of ethanol. So the formula is mass over volume times with 100 and we will get 21.42%.
Conclusion for this experiment is the ethanol concentration of one sample was successfully assessed via titration. The process entailed oxidizing ethanol with potassium dichromate to produce acetic acid, which was then titrated with standard sodium thiosulfate. The approach produced accurate and reliable measurement with consistent result for normal wine ethanol levels. The titration approach demonstrated precision with defined endpoint and reliable results. The approach was simple, appropriate for routine analysis and cost-effective, using widely available components. The experiment revealed remarkable accuracy and precision thanks to precise calibration and cautious implementation. Overall, this titration is a reliable and effective method to determine ethanol in wine, which is useful for quality control and regulatory compliance. In conclusion, the titration method is a strong and dependable analytical technique for determining the concentration of a drug in a sample. Titration produces reliable and reproducible results when performed precisely and carefully. Its simple approach, along with the use of common reagents, makes it convenient and inexpensive for routine analysis. Because of its accuracy and versatility, the method is used in a variety of domains, including chemistry, biology, and environmental research for quality control and quantitative analysis.